One day morning, Keat opened his laptop and logged into Spectrum.
Wow, highlight assignment again. Wow, still need video more. GG. I have no idea what to do. Hello?
Hello, Keat. Me and Jane is playing shop food at KIB1006 now. Wanna join?
No, we have dynamic video assignment.
Aiya, never mind lah. You come KIB1006, we can discuss together after the game.
Oh, okay, no problem.
A few moments later.
At KK1 we play and play and play and play and
2,000 years later.
Hi, it's me, Keat again. So our group finally decided to use short put as the topic for our case study assignment. Our group members are Audrey, Ying, Vissagan, and me myself. This case study is to achieve 3 LOs from real-life example of dynamics. LO1 solve dynamics problems of accelerating particles. LO2 solve problems of accelerating rigid bodies in 2Ds. LO3 analyze kinematics and kinetics problems in vibrating particle. So without further ado, let's get started.
For LO1, we'll be solving on the dynamics problem of accelerating particles. Based on our real-life example, which is short put, the data obtained from the real-life example is the height of metal ball release is 1.925 meter, the angle released from my hand is 30 degree, the horizontal displacement of the metal ball is 5.6 meter, and the velocity released from my hand is 8 meter per second. So it was divided into the x component and the y component, so this is the diagram drawn from the real-life example. So since it was divided into the x component and the y component, the initial velocity at the release point can be calculated by using the trigonometry formula. So the initial velocity at the x component is 6.9282 meter per second, while the initial velocity at the y component is 4 meter per second. So first of all, we can find the time of the ball drop to the ground. So the displacement of Sx is equal to the velocity at the x component times the time. So by using this formula, we can deduce that the time drop to the ground is 0.8283 seconds. Secondly, we can find the final velocity. First of all, we know that the initial velocity is calculated, and by using this formula, v square is equal to u square plus 2as we can find the final velocity at the y component. So the final velocity at the y component is 7.3327 meter per second. Throughout the motion, the velocity at the x component remains constant. So the final velocity is equal to the initial velocity, which is 6.9282 meter per second. So since we have the final velocity of the x component and the y component, we can calculate the final velocity by using this formula. So the final velocity is equal to 10.088 meter per second. Finally, we can calculate the angle of the final velocity when it drops to the ground by using tangent theta is equal to final velocity at the y component over final velocity at the x component. So by using this formula, we can deduce that the angle is equal to 46.62 degree.
Hi, I'm Ying. So now I'm going to explain LO2, which is solving problems of accelerating rigid bodies in 2D. So this is our free body diagram, and we can see that the weight is acting downward due to the gravitational force, and then the releasing velocity is at 30 degrees above the x-axis. This diagram shows the energy stored inside the metal ball at initial and final position. So to prove that energy is conserved, we can use the law of conservation of energy, which is T1 plus V1 equals to T2 plus V2. and T is the kinetic energy, which we use the formula half mv squared, and then V is the potential energy, which we use the formula mgh. So we substitute in the values and the assumption which we get at LO1 to prove that the left hand side is equals to right hand side. So to calculate the left hand side, we use half mv1 square plus mgh1, and so half times 1/2 times 4 times 8, which is our initial velocity, 8 square, and then plus 4, which is our mass of the ball, times the gravitational force, 9.81, and times with the height, which is Audrey height, and plus the length of vertical length of Audrey hand, which is 0.225, and then we will get 203.54 joule. And to calculate the right hand side, which is the final position of the ball, we use half mv2 squared plus mgh2, and so we subs 1/2 times 4, the mass of ball, and times 10.088 square, which 10.088 is the final velocity of the ball, which we have already obtained in LO1, and then plus 4 times 9.81 times 0, because this 0 is because the height from the ground is 0, and then we will also get 203.54 joule. So from this we prove that left hand side is equals to right hand side, which is 203.54 joule. So we can prove that energy is conserved. So that's all from me, thank you.
Hello everyone, I'm Vissagan here. So today I'll be presenting about my third learning outcome, which is analyzing kinematics and kinetic problems in vibrating particles. Here it shows, in this slide, it shows a trajectory motion diagram where my good old friend Audrey is actually releasing a shot put ball at a 30-degree angle, which causing it to eventually reach the ground and producing an oblique impact. And then looking further into this analysis, we can draw a free body diagram as shown here. The values from LO1, which will be presented by my teammate and calculated by teammate, represents the value of 6.9282 meter per second. That's for the velocity at x-axis, and velocity at y-axis is 7.3327 meter per second. And resolving the velocity after the first bounce, we can denote them into two components, which is the x and y component, and for each of the component we can represent them as vx2 and also vy2 as shown here. And then looking upon the oblique impact analysis and the formulas, we can actually calculate the velocity after the first bounce for the y component, and of course for the x component the value remains is constant because it is moving. There's no movement in the x direction, it's only at the y direction. So vx2 is fixed at 6.9282 meter per second. And then finding the velocity of the first bound at y component, we can use the formula of coefficient of restitution, which is shown in this formula. And upon calculation, we can get the value of y2, which is 5.4995 meter per second, and it's moving in the upwards direction. And then after that, we can also find the velocity, the resultant velocity of the first bounce by finding its magnitude, and as you can see in this formula, putting on the values in the formula can be evaluated into this value, which is 8.8456 meter per second. Now upon finding the resultant velocity, we can also find the angle of the metal ball after the first bounce, as you can see in this formula. Using the tangent formula, we can find the angle which represents the value of 38.44 degrees. And that's all for me. Thank you.
In conclusions, we can solve shot put problems using the fundamentals dynamics theory. There are some adjustments which can be made to improve your shot put's performance, such as release angles, release velocities, your physical attributes, and the technique used. So thank you for watching. If you like our videos, please thumbs up and share it to your friends. Bye!